You're given a set of vertical lines, where each line's height is given by an array. You can choose any two lines as the left and right boundaries to form a container with the ground. The amount of water this container can hold depends on two things. The height is determined by the shorter of the two lines, and the width is the distance between them. Your goal is to find the pair of lines that can hold the maximum amount of water. Let's look at an example. Suppose the array is 1, 5, 6, 3, 4, 2. If we choose the lines with heights 5 and 4, the distance between them is 3, and the water height is 4. That gives an area of 12. In this example, 12 is the maximum possible area. The most straightforward solution is brute force. You try every possible pair of lines, calculate the area each time by taking the smaller height and multiplying it by the distance between the two lines, and keep track of the maximum. This approach is easy to understand, but it's slow. There are about n squared pairs to check, so the time complexity is O of n squared. There's a much faster solution using the two-pointer technique. We place one pointer at the far left and another at the far right, and compute the area of the current container. Then, step by step, we shrink the container by moving one side inward and try new containers. The key idea is this: at each step, we only move the pointer at the shorter line. Why does this work? Because the area is limited by the shorter height. If we move the taller side, the width gets smaller while the height limit stays the same, so the area can't increase. But if we move the shorter side, we might find a taller line, which can compensate for the reduced width and potentially produce a larger area. We keep doing this until the two pointers meet, and the largest area we've seen is the answer. Let's walk through the example. At the start, the left pointer is at height 1, and the right pointer is at height 2. The width is 5, so the area is 1 times 5, which is 5. Since the left side is shorter, we move the left pointer to height 5. Now the width is 4, and the area becomes 2 times 4, which is 8. This time, the right side is shorter, so we move the right pointer to height 4. The width is 3, and the area is 4 times 3, which is 12. Continuing with the same rule, the next areas are 6 and then 5, both smaller than 12. When the two pointers meet, we stop. The maximum area is 12, formed by the lines with heights 5 and 4. The Python implementation is simple. We use two pointers starting at both ends. At each step, we compute the area using the shorter height and the distance between the pointers, update the maximum, and move the pointer at the shorter side. When the pointers meet, we return the maximum area. This runs in O of n time with O of 1 extra space.